Okay, so today we're putting a material on the stand that you probably think you know really well. You know, the stuff in your pencil, that slick black powder for a rusty lock? But what if I told you that exact same stuff is also the key, like the key, to the entire electric vehicle revolution? Yeah, let's get into it. We're talking about graphite. So that's really the big question we're tackling in this explainer, isn't it? Is graphite just, humble pencil lead? A relic from the analog world? Or is it some kind of high-tech monarch, silently powering the entire 21st century? The answer? Well, it's not as simple as you might think. It's complicated. And that's exactly why we're here. We're going to put graphite on trial. We'll look at all the evidence, the good and the bad, weigh its incredible history against its very real flaws, and by the end of this, we're going to deliver a final, definitive verdict on where it really ranks in the hierarchy of materials. All right, court is officially in session. The defendant today, graphite, a layered form of carbon, and it stands accused of being both completely indispensable and deeply flawed. So, before we get into the arguments, let's start with the basics. Let's get a really clear picture of what we're actually dealing with here. So the most important thing to get is its hexagonal structure. Just picture these flat sheets of carbon atoms, kind of like layers of chicken wire, stacked one on top of the other. Now the atoms in each sheet are bonded super tightly, but the bonds between the sheets, they're really, really weak. And that one simple fact, that unique structure, that's the secret to pretty much everything graphite can do. All right, let's call the first witness for the defense, history itself. I mean, graphite has this long, amazing past, right? Its contributions to civilization are just undeniable. Let's take a look at how this layered material built its own, you could say, layered legacy. And this timeline, wow, it just perfectly captures its journey. First, it gave us the power to easily write things down, to record our thoughts. Huge. Then, fast forward to the 1940s, and it's helping kickstart the entire nuclear age by controlling chain reactions. I mean, come on. And then, in the 90s, it becomes the key that unlocks the portable power of the lithium-ion battery. So you go from writing to nuclear power all the way to your smartphone. That is quite a resume. So you have to ask, why? Why was it picked for these totally different, incredible jobs? Well, it all goes back to its basic properties. Remember those weak bonds between the layers? That makes it super slippery, an awesome dry lubricant. And the electrons flowing freely inside those layers? That makes it a fantastic conductor of electricity. Plus, the strong bonds within the layers mean it can handle insane amounts of heat. It's this exact combination of superpowers that makes it so incredibly versatile. Okay, now it's time to call our star witness, and that is the modern world itself. Because right now, today, there is one single use that puts all the others in the shade. It's the one thing that cements graphite's status as a critical material for our future. Yeah, we are talking about its role as the absolute, undisputed king of battery anodes. Whoa, okay, look at this. The thing that jumps out here is just the total dominance of one sector, a massive 60%. 60 of all graphite demand now comes from batteries. We're talking your phone, your laptop, and the big one, electric vehicles. Yeah, steelmaking is still a big piece, but pencils, look at that. It's just a tiny little sliver of the pie now. And to keep up with that demand, we're cranking out something like 1.5 million tons of this stuff every single year. This is not some niche material anymore, folks. It's a massive global industry. It's a foundational piece of our entire energy transition. And get this, it's not slowing down, not even a little. The market is just exploding. We're talking a growth rate of around 15%, compounded every year. That is just a blistering pace, and it's almost all being driven by one thing, our insane demand for EV batteries. Now sure, the stuff you dig out of the ground, natural flake graphite, can be cheaper, but the ultra-pure synthetic graphite that you need for high-performance batteries and stuff, that commands a serious premium. We're talking up to $10,000 a ton. So let's be clear, this isn't just pencil dust. It's a high-value, precision-engineered material. And with that, the defense rests. But it's not over yet. Now it's time for the prosecution to have its say, because for all its strengths, and there are many, graphite is far from perfect. There are some serious cracks in its crystal structure, both literally and figuratively, that we absolutely have to talk about. First up, where do we even get this stuff? Well, you've got two main choices. You can mine it from the ground. That's cheaper, but it's often full of impurities, and the supply is heavily concentrated in just a few places. Or you can basically make it from petroleum byproducts. This gives you amazing purity, but it uses a ridiculous amount of energy and, well, it costs a fortune. So right away, you see the problem. There's no easy, perfect answer here. And the list of problems just keeps going. The dust, it's a serious health hazard for miners. It can actually burn in the air if it gets too hot. The supply chain is super volatile. The mining itself has some pretty big environmental impacts. And even in its star role inside batteries, it has technical limits. The whole structure swells and shrinks when you charge and discharge it. And over time, that degrades the battery's performance. All right, all the evidence is on the table. We've heard the case for, and we've heard the case against. So now, it's time to weigh it all up and deliver the final verdict. We're going to score graphite against our 6 official criteria to figure out, once and for all, where it ranks. Okay, let's pull up the official scorecard and see how this breaks down. First, historical impact. We're giving it a strong 8 out of 10. I mean, pencils, steel, nuclear power, it's essential. Next, mechanical properties, an 8.5. Its conductivity and slipperiness are top-notch, but those dust and oxidation issues hold it back a bit. Workability gets a solid 8. It's pretty easy to shape. Scalability and cost, another 8. It's abundant, yeah, but that super pure stuff gets really pricey. And finally, versatility and lasting relevance both get a fantastic 9. I mean, it dominates so many industries, and it is, without a doubt, the king of battery anodes today. So when you take all of that into account, the final verdict is in. Graphite lands solidly in the high A tier. Look, its incredible versatility, its amazing properties, and its absolutely central role in the energy transition make it a total powerhouse, no question. But those challenges, the supply chain issues, the environmental impact, and its own physical limits, they just keep it from reaching that legendary S tier. And really, that's the bottom line here. It might not be as flashy as a diamond or as, foundational as steel, but graphite is this quiet, essential layer that just makes so much of our modern world possible. It wrote our history, it enables our industries, and right now it is literally conducting and lubricating our progress into an electric future. The big question, though, is for how long? As technology keeps evolving, will it be able to hold on to its crown?